So I've taken the data set and I've saved it into my downloads folder here in on my computer. We're going to need to import this into R. So I'm going to press import dataset from text. Okay. If this is the first time that you've used the import dataset button, it may prompt you and say, download something, in which case you should do that. Once you've downloaded that, this should pop up. And I'm going to navigate to downloads where I saved my folder, and there's my data file. Okay. So here's the file, the raw file. It's a CSV file, which means all my data is sort of separated by commas. Okay. And R usually does a fairly good job of recognizing, how to format things. So in this case, you can see that all the data sort of falls in columns, and you can see that it's recognizing the first row here as being sort of the names of those columns. If it wasn't formatting properly, you can fiddle with some of this stuff to see if you can get it to read in more nicely. But so far so good. So again, it's going to import it in as a data set called NC, and it's going to look like this, which is what we want. So I'll just press import. Okay. It gave me a warning, which is sort of weird, but here we go. So they've sort of copied some code to import in the data. You can see the data here is in the environment, right? So there's 1,000 observations. There's 1,000 different rows for the 1,000 different babies that were born. And we've got information on 13 different variables. So we know the data is imported in R because it's available in our environment. And then over here in this window, it sort of popped up a preview of that data. So we can see all the different rows for all of the different babies. And then each column here represents each of those different variables that were recorded on each birth. And in this particular case, we're interested in the weight of the baby as well as the habit, so the smoking habit of the mother. You can close out of this preview of the data. The data is still read in. All you have to do is click on this little NC again, and it will pop up the preview if you ever want to look at it. Okay. So the first thing for our analysis here is they've asked us to make a side-by-side box plot of the habit and the weight. So we've talked about looking at box plots before. I don't know how much we've talked about creating them. The first thing that I'm going to do is just attach my data set. So I'm going to say attach NC. Okay. And that's just an error I'm getting because of something I did before. But so that just means that North Carolina NC is going to be the only data that I'm going to work with. Just make this font a little bit bigger for you. So from here, in order to create the box plot, I'm going to use box plot. Then the numeric variable always goes first. So I'm going to use weight. Okay. And then I'm going to do a little tilde. So the little tilde is this little squiggly. It's usually in the top left-hand corner of your keyboard somewhere. And then I'm going to do habit. So this is going to take the weights of the babies and create box plots for each of the weights, but there's going to be a separate box plot for each habit. Okay. If I press enter, it's going to give me an error here because this window is not large enough to display it. So let me just make this window a little bit bigger and we'll try it again. And there it is. Maybe if I make my window a little smaller here. There we go. I can't have the font big and the plot big, but there we go. Okay. So this box plot code created this. It's a side-by-side box plot. So we can see both of the different groups for habit. And we can see that there's the non-smoking group and the smoking group. And then we can look at the distribution of the weights. This allows us to compare the center of the two distributions. And in this case, they look pretty similar, actually. I think the median and the interquartile range is maybe slightly higher for the non-smoking group compared to the smoking group, but they don't feel, too drastically different, right? And then we can also get a sense for the spread, right? And you can see that the non-smoking group seems to be spread out a little bit more, right? The range is much wider than it is for the smoking group. So this gives us sort of a preliminary look at sort of what's going on here between the two groups. But of course, we're going to have to do more analysis to see whether there truly is a difference in the mean birth weight between the two groups. Okay. The next thing that I want us to do is to calculate the mean weight for each of the different groups. And so we can do that quite easily in R. Our code is tapply. Let me make the font bigger again so you can see it. So the code is tapply. Okay. You're going to put in the numeric variable first. So in this case, it's weight. Then we're going to put in the categorical variable, which in this case is our habit, and then you tell it what function you want it to compute. So I'm going to go with mean. Okay. When I do that, it's going to spit out the sample mean for both groups. So this is the sample mean for the non-smoking group. Maybe we'd call that X bar 1. And here's the sample mean for the second group, X bar 2. Okay. We could change this code, so we could change mean to be whatever sort of function we want. So let's say I was interested in the standard deviation. I could change that to standard deviation, and it would spit out the standard deviations of the two groups. Okay. Once we sort of have our summary statistics and a preliminary look at what's going on here, they've asked us to conduct a hypothesis test to determine whether the average birth weight is different between the two smoking habit groups, so between the smoking and the non-smoking group. Okay. So a couple of different things that are going on here. We know that we've sort of got two different groups. And I'm asking myself whether or not I think the data is paired. And in this case, the data is not paired, right? You know, it wasn't like there was one mother that smoked and then stopped smoking or something. These are two sort of totally independent populations. There's a whole bunch of non-smoking mothers and then a whole bunch of smoking mothers, but there's really no relationship between the two. So we know that we're doing an independent t-test. One thing we might need to figure out what we're going to do is whether or not to pool the variances or not. In this case, you know, just looking at this box plot, you know, I wouldn't say the variances look drastically different, but we do have a test to be able to determine to see whether or not we should pool the variances or not. And so that was when we took S1 squared and divided it by S2 squared. So that's these two numbers here, right? So I can take this number, that's the standard deviation for the first group, and square it. So that gives me the variance for the first group, and then divide it by the variance for the second group. Okay. And that's going to give me some number. Okay. Remember, the rule is that if we take this ratio, if it gives us some number between 1/2 and 2, then we decide to pool the variances together. If we get some number less than 1/2 or more than 2, then we're not going to pool the variances together because the standard deviations or the spread of the data is just too different. In this case, we're getting some number between 1/2 and 2. So that means that we're going to need to go through and pool the variances together. Okay, we can assume that the variances of the two groups are equal. Okay. So all of that to say, we're going to use t.test. Okay. And I can tell it the same way I told it here with weight and habit. I want to do a t-test of the weights comparing between the two habit groups. Okay. And then I'm going to say var.equal is equal to true. Okay. And that's because I'm assuming here that the two variances are equal, right, between the two groups. And I'm assuming that, 1, because they look fairly equal, and 2, because we did our little test and this number gave us something between 1/2 and 2. Okay. Other things we might want to specify, maybe I'll specify my confidence level. Let's do 95%. And then I might also tell it to do a two-sided hypothesis test. Okay. So I'm going to run this code, and it's going to spit out my results. Okay. See if I can just get it to look prettier here. Okay, so we've got our test statistic, right, is 2.2034. Okay. It follows a t-distribution with 997 degrees of freedom, and it gives me this p-value of 0.02779. Okay. And so in this particular case, right, we were testing the null hypothesis that the two means are the same against the alternative that the mean weights or the mean birth weights are different between the two groups, the smoker and the non-smoker group. And if we were doing this test with 95% confidence, this p-value would be smaller than the alpha rate of 0.05. So I'm going to reject the null hypothesis. I have significant evidence here to say that the birth weights are significantly different between the two groups. Okay. So we have some pretty strong evidence here to suggest that smoking status, the mean birth weights are different between the two groups. I'm going to hesitate to say, I can't say for certain that the smoking is what caused the birth weights to be different. There could be some other variables here, in place. This was not a randomized study where we assigned people to smoke or not smoke. That would be very unethical. But, we've got this case where, there could be something else going on, right? Maybe it's diet, right? There might be very different diets between the smoking and the non-smoking groups, or other access to certain things that might be different between the two groups. So I can't necessarily say the smoking is what caused the difference in weight, but I do know for sure that between the two groups, the birth weight is significantly different between the two groups. Okay, and if I wanted to know specifically how different, okay, I could look at my confidence interval here, right? And so my confidence interval is my 95% confidence interval. I'm 95% confident that the difference between the two means is something between 0.03 of a pound and 0.6 of a pound. And so you can decide for yourself whether you think that's a practical difference or not. I don't know whether 0.03 of a pound is enough to sort of be concerned about, or is 0.6, is that enough of a pound to be concerned about in terms of, outcomes for these babies going forward. I'm not a doctor, I don't know, but this helps to quantify that difference a little bit more. And remember that it matches up, right? So here I decided to reject the null hypothesis. I rejected the fact that the null hypothesis that they're equal, and I went with the alternative that the difference was not equal. So 0 was not a plausible value for the difference. And you'll notice that 0 is not contained within this interval. This interval only contains positive values. And in this case, they would have done non-smoker minus smoker, which is why I'm getting the positive values for my confidence intervals, right? Meaning that the smoking group was higher than the non-smoking group. R by default always does this in alphabetical order. So they did non-smoker minus smoker. But, we could set this up to do smoker minus non-smoker, and then these would have given us negative values. Either way. Okay, so I think that's all that you need to be able to do this in R.